Welcome to the next lecture on Introduction to R software course. You may kindly recall that in the earlier lecture we had discussed about some basic preliminary calculations in R, and we had explained you that how one can operate the addition, subtraction, as well as for the addition and subtraction for vectors where we have more than one values at a time. Right. We will continue with those things, and we would like to explore some more aspect of basic calculation where I can use this R just like a simple calculator. So, now we will try to discuss about the integer division in R. The first question comes, what is an integer division? So, the division in which the fractional part, which is the remainder, that is discarded, that is called as integer division. For example, in case if I want to divide 2 by here 2, then we can see that here the answer will be, divisor will be 1 and 2 ones are 2 and the remainder will be here 0, right. So, in this case when I try to say that I am trying to do the integer division of 2 with 2, then the answer will come out to be 1, which is the divisor, and this remainder part is discarded, right. The symbol for doing the integer division in R is percentage sign backslash percentage sign. So, in case if I want to do the integer division of 2 by 2, then I have to write here 2 percentage backslash percentage and 2, and this will give us the answer to be equal to here 1. So, now I try to consider combined values of 2, 3, 5 and 7 in this vector, and I would like to do the integer division with respect to another vector which is containing 2 values 2 and 3. So, now there are two things that you have to observe. First thing, how this integer division has been made, this I already have explained you. The second aspect what you have to see that this integer division is organized in this way. This 2 is divided by this 2, this 3 is divided by this 3, and once again this set of values, they are operated over the values 5 and 7, and so 2 is, so 5 is integer divided by 2 and 7 is integer divided by 3. So, in this case you can see now here that 2 is being divided by 2 with respect to integer division, the answer comes out to be 2 ones are 2 and the remainder here is 0. Similarly, here the remainder comes out to be 0, and similarly here the remainder comes out to be here 1, and similarly here the remainder comes out to be here 1. So, now you can see here this is the integer part of the division, which is here 1, 1, 2 and here 2, and these 4 values are reported over here 1, 1, 2, 2, and the screenshot of this thing is given over here, which I would request all of you to do it with your own hand, right. Similarly, when we try to go for modulo division, and in mathematics that is written that when I am trying to divide x by y with respect to modulo division, we try to write it with x mod y, and the notation in R is double percentage sign. What really happens in the modulo division? Actually, modulo division finds out the remainder after division. So, now I will try to take an example where I have taken 4 values 2, 3, 5 and 7 which are combined in a vector, and I would like to operate the modulo division with respect to here 2. So, in this case what you have to observe that each of these values 2, 3, 5 and 7, this is being modulo divided by 2. So, I am trying to do it here in this way, say 2 divided by here 2, and answer comes out to be 2 ones are 2 and remainder here is 0, and similarly 2 divided by here 3, answer comes out to be 2 ones are 2, remainder here is 1. Similarly, 5 divided by 2, 2 twos are 4, remainder comes out to be here 1, and 7 divided by 2, answer comes out to be 2 3 6, remainder here is 1, and now this 0, this 1 and this 1, which are the remainder, which they are reported here as 0 1 1 1. So this is the procedure for the modulo division, right. And when you try to do it over R, means I can just show you here just for the sake of understanding. You can see here this is the same answer, and this is the slide which is being copied and pasted over here, right. So this is how we try to operate the modulo division. And similarly, now in this case, in say another example, I will try to do the modulo division of a vector with respect to a vector. So here I am trying to take 4 possible values 2, 3, 5 and 7, which are combined by a vector, and similarly I am trying to consider another vector. There are 2 values 2 and 3, which are combined by a vector containing 2 and 3. So what will now happen, this 2 will divide this 2 and this 3 will divide this 3, and in the next step the same set of values 2 and 3, they are going to operate with respect to 5 and 7. So what will happen here, that 2 is being divided by 2 with respect to the modulo division, or we call it say 2 modulo 2, and similarly this 3 is being modulo divided here by here 3, and the 5 is being modulo divided by here 2, and 7 is being modulo divided by here 3. And the screenshot of this operation in R is given over here. This again I would like to request you to operate it with your own hand on your computer. Okay. Now there are some built-in function in R which can give us the direct answer. For example, suppose I want to find out the maximum value among certain given number of values, then the function here is max. So max is the function which is already built in inside the R package, and as soon as you try to find out the maximum of several values using this operator max, it will finally give us the maximum among those values. So I will try to take here one example and will try to show you here. For example, I am trying to take here 3 values 1.2, 3.4 and say minus 7.8, right. And when I try to operate the function max here, then I try to write all these values inside this bracket, means maximum, and inside the bracket all the values, they will be written separated by a comma. And when I try to operate it, you can see here out of 1.2, 3.4 and minus 7.8, 3.4 is the value which is maximum among all the 3 given values. So the answer comes out to here 3.4. And similarly another approach to do the same thing is this, that I can combine all the same value 1.2, 3.4 and minus 7.8 by this combined operator, and then I try to find out the maximum value. This will also give us the same answer. So just for the sake of illustration, I try to show you here that how we can obtain it. So just for the sake of understanding, I try to take this command and I try to operate it here, I try to paste it here, and as soon as I press enter, I get the value here 3.4, right. Similarly, we can also find out the minimum. In this case, the command is min, which is the short form of minimum, and the rule here is again the same, just as we did in the case of maximum, that I would try to write down the minimum, and inside the bracket I will try to write all the values which are separated by comma. So here you can see I have considered here 3 values 1.2, 3.4 and minus 7.8, and when I try to do this minimum of these 3 values, the answer comes out to be minus 7.8. And the same thing I can also do in say alternative way, that I can combine all the 3 values with this combined operator C, and I can write all these values inside this bracket, and then I try to use the function min. So, minimum is again another function which is built in inside the base package of R, and it can, and you can directly obtain the minimum value from some given set of values. Right. Similar to maxima, maximum and minimum values, there are some other values which are already given in the base package. Right. For example, if I want to find out the absolute values, then the function is abs and inside the bracket, and the pattern here is the same, that we try to write down the abs function and then all the values separated by comma. And similarly, in case if I want to find out the square root, the function is sqrt, and again all the values are written inside the bracket. And yeah, in the next slide I will try to take some example to show you that how these things are being operated. And similarly, for rounding of a value, we have a function round, and again if I have more than one values, I can give all the values inside this bracket separated by a comma. Similarly, in case if I want to one value up and one value lower, then we have function here floor and ceiling. And similarly, if I want to find out the sum of several values, I can use the built-in function here sum, and again inside this bracket I have to give all the values, and the outcome will be the sum of all the values which are prescribed inside the bracket. The next command is product. Suppose I want to find out the product of several values, so I have to write down all the values inside a bracket separated by a comma, and then I have to use this operator prod, and this will directly give us the product of all those values. Right. Similarly, log values, log with base 10 and log with base 2 and so on, all these values are built in inside the R package, and depending on your need you can use them directly without writing any additional program. Similarly, in case if you want to find out the exponential of certain function, I can use the function exp, and for some trigonometric function we have sine function, cos function, tan function, a sine, a cos, a tan function. They can be operated in a similar way, and hyperbolic trigonometry functions are also there, like as sin h, cos h, tan h, and a sin h, a cos h, a tan h. So, all these functions you can see here, they are already built in inside the base package of R, and whenever you need it you can use it. Now, let me demonstrate some of the functions that how one can use it. For example, if I want to find out the absolute value, you can see here I am trying to take here a negative value -4, and I am trying to operate this abs function. So, if I try to write down abs function and inside the bracket values, then the answer comes out to be 4. Obviously, the absolute value of -4 is 4. And similarly, if I have more than one values, then for example, if I try to take 5 values -1, -2, -3, 4 and 5, and suppose 3 values are here negative values, and if I try to operate the abs function or the absolute function over this vector, the answer comes out to be 1, 2, 3, 4 and 5 like this. Why? Because the absolute value of -1 is 1, absolute value of -2 is 2, absolute value of -3 is 3, and absolute value of 4 is 4, and absolute value of 5 is 5. So, you can see here that this absolute function operates over each and every element in your combined vector, and this is here the screen output of the same operation. So, you can try it yourself. Right. Similarly, if I want to find out the square root, we already have a function sqrt, which means square root. So, suppose I want to find out the square root of here 4. So, this can be written as here like this sqrt and here 4. So, the answer comes out to be here 2. And similarly, in case if I try to find out the square root of more than one values, then all those values they have to be combined inside a vector, and then this square root function is operated. So, you can see here the square root of 4 is here 2, square root of 9 is 3, square root of 16 is 4, and square root of 25 is 5, and this is the answer which is obtained over here. And this is the screenshot of the same operation when you try to do it in R. And some more example. suppose I want to find out the sum of 4 values 2, 3, 5 and 7, that is I want to find out 2 plus 3 plus 5 plus 7. Then in that case I can combine all these values inside a vector using the C command, and then I will have to use the function sum. So, sum of all these values will come out to be here 17, and you can see here this is the screenshot, right. Similarly, in case if I want to find out the product of 2, 3, 5 and 7, that means I want to know the value of 2 into 3 into 5 into 7. So, in that case I simply try to club or combine all the values inside a vector using the C command, and then I try to operate the function PROD, that means product, and 2 into 3 into 5 into 7, this comes out to be 210. Now, suppose I want to find out the round off value of 1.23. So, I try to use here the function round, and inside the bracket I will try to write down the value 1.23. So, we know that the rounded value of 1.23 is 1. So, as soon as you write down this command in R and press enter, you will get here the value 1, and this is here the screenshot. And similarly, if you want to find out the round off value of 1.83, then definitely it is more than 1.5. So, it is going to be 2, and if you try to do this command in R, you get here an answer 2, and this is the screenshot of this function. So, you can see here all these functions, sum, product, round off, they can be directly operated over the R without any problem, right. Okay. Now, I come to another aspect, what is about assignments. Assignments, we already have discussed that how do we assign a value to a variable. For example, if you remember earlier we had discussed that if I define a variable x and if I write 2, that means I have assigned the value 2 to a random variable x. So, the same thing here, I try to do it here by writing x less than hyphen 6, or I can also use here directly here x equal to 6, and then I try to check the value here. This gives me here the value of x is here 6. Now, I would like to show you something else, that suppose I want to find out what is the mode of x. One conscious, I am not finding out the mode, it is a statistical function in the topics of mean, median and mode. But here I am trying to find out the mode of x, meaning thereby what is the nature of x, whether it is numeric or not. So, as soon as you try to do here mode of x, you will see that the answer comes out to be here numeric. For example, I will try to show you here in the R function itself. Suppose if I try to write down here x equal to here 6, and then I press here x, this is giving me a value 6, and now if I try to write down here mode of here x, then this is here numeric. So, this is trying to indicate that x equal to 6 is a numerical value. So, let us now come back to our slides, and the next thing similarly I can operate this thing over a vector quantity also, right. Suppose I try to define here a vector x1 which is combining 4 values 1, 2, 3 and 4, and then I try to assign a different value, that I am trying to define here another value here x2 which is x1 square. So, I try to write down here as say here x1 hat 2. So, obviously the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, and the square of here 4 is here 16. So, you can see here that now 1, 4, 9 and 16 are coming over here. That means this x2 has been defined over a vector. So, the moral of the story is this: I can use this assignment function over a scalar quantity having only one value, as well as I can use it over a vector quantity having more than one values. And here you can see here that this is the screenshot of the same operation being done in R. And here means you have to keep in mind that as I told you earlier that R is case sensitive, means capital X and small x, they are different, they are not the same. So, that you have to keep in mind over here, right. So, with this slide I would like to stop here. And I would like to request all of you that you please try to practice all these assignments, taking different types of example, and whatever example I have taken, try to take some other values, try to make them more complicated, try to take some question from the assignment, some question from say other books, and try to practice it. Till then, goodbye.